Hello everybody and welcome back to our Excel class. This video is on scatter plots. Now scatter plots are probably one of, if not the most important types of graphs that you can make in Excel. Scatter plots are used to show raw data. And if you're in any sort of the natural sciences, think biology, chemistry, physics, almost every plot you're going to make should be a scatter plot. And this is because you want to show the actual data points. You don't really want to show fitted curve of the data points. You want to show the data points. This is further underscored by the fact that scatter plots are seen in almost all published scientific papers and so on. To get a scatter plot, what you're going to do, just like in every other plot, we're going to go to Insert, and then all the plots come up, and we're going to hit Scatter Plot. Now, 9 times out of 10, you're going to want to do this one, which it just has the data points. And it comes up a blank graph. Now, to get data into our graph, we're going to right-click, we're going to hit Select Data, we're going to add some data. We can name it whatever we want. We select our X series. Now, be sure not to select the name with the data. That can make things a little wonky. And then for our Y series, and then hit OK. Hit OK. And then we see we have our scatter plot. Now, to add more things to the scatter plot, you can either click up here, choose what you want to add, or over here, this plus button. We need to add some axes titles, and then with a scatter plot, we have to add a trend line. Now, the trend line will be different depending on what you're doing. You might also need to do a propagation of error, but we don't need to do that for all intents and purposes. We're going to add a linear regression, but more than that, you have to hit more options. Now, it's going to give you a whole bunch of different options. We picked linear because this looks approximately linear, but there's also exponential, quadratic, other sorts of polynomials. You can fit whatever it is you need to fit, depending on what data you have. So, when you have a trend line, you also need to include 2 other things. You need to show the equation and the r squared. Now, what is the equation, the r squared? The equation is pretty self-explanatory. The equation is the equation of the trend line. It gives you the y-intercept. It gives you the slope. Oftentimes, we're looking for the value of the slope because that's what the data is used for. The r squared value tells you how closely your data matches up to the given trend line. Now, the r squared is going to be, the closer the r squared is to 1, the better. The further it is from 1, the worse. And r squareds go from 0 to 1. So an r squared of 0.001 is not a great fit, but an r squared of 0.999 is a pretty good fit. Now, through statistics and data, the r squared is never going to be perfect. And just because you have a very good r squared value, meaning very close to 1, doesn't necessarily mean that you have good data. And likewise, if you have an r squared that is not close to 1, it doesn't necessarily mean you have bad data. All right, to finish off this chart, all you have to do is add a title that makes sense given the data, add some axes labels, be sure to include units. This is very important. And, of course, format the table properly, and you should be all set. Thank you. Have an awesome day.